Okay, I got a little carried away. I started giving examples in vectors, and I started really just like throwing around some extra little syntax that I think might be kind of useful to anyone writing C++ code. So you're definitely getting your money's worth with this video. We'll start from the very basics. We'll just step through this code line by line. We'll talk about what it's doing. We'll talk about why I have code in certain places that I have it. I'm throwing in a little bit of boost stuff here as well, just to give you a little teaser for what's coming. So let's start at the top. So when I first sat down to write this source code, I defined this vector with the little brackets int, and I called it vector of numbers, and I gave it 4 numbers, 1, 2, 3, 4, right? So this is essentially how you use the containers in the STL language. What this is called templating in C++. So essentially what I've done is I've said, okay, give me a vector and make it a vector of ints. By giving it those brackets, I can put, essentially in C++, I can put any type I want inside that vector. So if I wanted to define a vector of, say, floats, right, instead of ints, that's how I would do it. So now I can put any sort of floats I want into that vector. This allows the data structures to be very flexible in C++. So after that, I was like, well, maybe I could show a couple different examples of how to iterate through these vectors or through this vector and print out what's in it. So the vector gives you a field. It's an object in and of itself. It's a class with an object, just like anything else. Like I said, it has iterators inside of it that give you access into the data. It also has a property called size, which tells you how many elements are in that vector. So here I'm using that property size, saying, okay, there's 4 of them. Give me the size of the vector. We're going to start from 0 up to the size of the vector, and we're going to print out everything that's in that vector. So if we actually run this code, we'll see a bunch of extra stuff, right? Let's comment that out for now, just so we don't get confused. Oops. We'll comment this code out and then run this, and we should see 1, 2, 3, 4 printed to the console. So I'm compiling it just like I always do, and there we go, 1, 2, 3, 4. Note that I'm also printing out a little space in between the numbers and then the end line character at the end of that. We've already seen the for loop previously, right, in the other video, so this shouldn't be anything new here. However, what these data structures give you is access to these iterators, which allows you to write very, very concise for loops. If we look at these lines here, let me set the number here. Whoops. So we can see what line numbers we're talking about. 26 to 29 here, right? You can see here this is the exact same for loop that I wrote up here, but it's much more concise, and it's actually safer because I'm not doing anything with this I variable. I'm not doing anything. I'm not taking the size of the vectors or anything like that. I really am taking every single iterator. What's happening here is every single iterator, and I'm assigning it to a variable called number, and I'm printing that number out. Here you can see I'm using the auto keyword. The auto keyword in C++ is just, I think it's, what is the phrase for that? There's a phrase in it in programming languages and compilers where I think it's called type inference or something like that. It's type inference. What it means is the compiler is able to tell what variable you're putting into that that chunk of memory, essentially. So the compiler knows, okay, this is an iterator of this vector, and then it will dereference that even further and say, okay, what is in that iterator? Well, it's an integer. I know how to print out an integer, and so it just gives me this integer here. If you print out what the type of this number is, it will tell you it's an integer. Even though you could put anything again in this vector. We could have put floats, we could have put strings, we could have even put those structs we were talking about in the one of the very first videos. the compiler will still know how to reference that using this auto keyword. So that's that. On line 24, what I'm doing here is I'm showing you that the vector allows you, as I said, it allows you to dynamically shrink and grow its size. Here I'm just pushing an integer of 1000 at the end of the vector. The reason I decided to write this second different type of for loop here is I thought, oh, let's print out what's in this vector now that I've added this 1000, just to prove that it's been added to the back of the vector. And I thought, oh, instead of writing a typical for loop like we've always done, let's add a little bit of syntactic sugar. So if you ever see this in anyone else's code, don't freak out. It's just type inference. So let's compile it. Let's prove that. Oh, what's happened here? What's going on? Oh, I didn't write the code to the. See what I mean? See, aren't you glad? I told you. I'm gonna show you the raw footage, right? You're gonna get everything, even the mistakes. So what happened there is I just forgot to write the code to the file. So now we're seeing again that this 1000 is at the end of it, and we're using this new syntax here. Another thing I did is I showed that you could put this in a function. That was my original intent. I started writing it as a function, and I said, hey, why not? Let's start looking at this auto keyword and this for loop. Another little chunk of syntactic sugar, another way we could have printed out this vector is this way. One thing I mentioned in the earlier videos is STL gives you access to this library called algorithm. Up here, you'll see I've included this algorithm library, and in that is the for each. So essentially what it does is you pass in these iterators. Let's back up one step. So we have this vector of numbers. As I said, there are things called iterators built into these data structures, right? And they give you insight and access into different aspects of the data. For the most part, they're essentially pointers. So here we have a pointer to the beginning of the vector, and we have a pointer to the end of the vector. So this allows me to run a for loop, essentially like I did up here with this auto keyword. We're doing a for loop for each for every element inside this vector, starting from the beginning iterator to the end iterator. I'm running this what they call a lambda function. We can talk about that after, and printing out every number essentially inside this for each loop. What this allows, the reason these are important and why they're a big deal is what this allows you to do is you can kind of play with what chunk of the vector you actually want to print out. So here I could print out +1. Maybe I want to ignore that first element. Well, I can start at the iterator +1 and do a for each there. To prove that, let's first run it regularly. We should see the same thing printed out twice because it's the same for loop, right, as expected. But now let's say I decide I want to skip printing out the first element of the vector, and you see now that it works. So that's why those iterators are very important. So like I said, let's talk about this lambda function here. So this is what in C++ is called a lambda, and it's like kind of allows your code to be much more precise syntactically. I only needed this one line to essentially define a function, pass in a parameter called int number, and then print it out, right? It's doing the same thing that's going on up here, where I'm taking having 4 or 5 lines to do something very trivial and simple. Anytime you have a small, tiny little function that can take care of something like this, you can use the lambda for that. It can be used all over the place, but in this case, I used it in the for each loop. Okay, so similarly to pushback, we also have popback, right? And what this will do is it will remove the last element of the array. So now that the last element of the vector. So now that 1000 is gone after running popback, and we can print out using this lambda once again and see what this looks like. And again, we see the 1000's gone. Another thing you can do is you can access the front element in the vector. Again, because we have this iterator, the begin pointer, we can access anything at the front of the vector. So let's print that out, and we can see we have access to that as well. Another thing we can do is access vectors like this with the at function, or we can access vectors like this. So in both of these cases, we'll get the same value. Why would you use the at function, you ask? Well, you can see here in the try catch that I've written previously. Using at will throw an exception for you, so you can actually handle the case where you're trying to access something out of bounds. It's a little bit safer than just raw access of the vector directly. See, and here you can see that I'm catching this exception that's scoped by the standard out of range exception. Actually didn't need that standard because I've used namespace up here, but whatever. And printing it out saying, hey, you're trying to access index 100 and the size of your vector is only 4. You can't do that. So those are vectors. Like I said, I went a little overboard. I got a little excited. It's been a while since I've written C++ code, so it was nice to flex my muscles again. One thing, like I said, I'll point out is I toyed around a little bit with the boost library here. So this is how you would, if you were going to include the boost library and use it, you'd do that in much a similar way here. I'm including boost, the lambda.hpp. I'm using it here in the for each loop, and I'm scoping into the lambda and getting this _1, which is very similar to what's happening here in the actual C++ STL lambda that I'm using below. Again, we'll get more in depth how to set up lambda. There's a little bit of tricks to it. It's nothing huge, but you need to pass in more command line arguments when you compile the code, things like that. So we'll have a video specifically for that. But I was like, oh, I'll toy with it now. In the next video, we'll dig into some other STL data structures. The vector is kind of the simplest, but we're getting the general idea of how to interact with the STL library. They don't change much, really. It's just the properties of the underlying data structure change. The interface to you as a programmer doesn't change much. So we got a lot of really good information in this video. We'll start talking about some more advanced data structures in the next video. See you then.